Hey, Vlad here, devinsideyou.com. Welcome to another video. This is part 4 of the Tagless final series, and today we're going to finally introduce hardcoded types. This is going to be the most exciting yet very challenging part in the entire series, but I'm sure that we're going to get through it just fine. This video has a lot of potential to get super long, so I might end up splitting it into two. Sorry about that. Anyway, let's get to it, shall we? So this is pretty much where we left off. We have our main, we have our expressions, we have our interpreters, the evaluate and the view interpreters, we have our program. And by the end of the previous video, we realized that in the division, it is not enough to return an option, okay? It is not enough because we want to return a left over here was one reason, a left over here was another reason, and a right over here. So what are we going to do? We're going to rewrite this whole thing again, remove the options and put an other in there. Well, yes, we're going to rewrite everything again, but this is going to be the last time. And for this, we're going to use the same trick as we used actually 2 videos ago. If we go to expression, and remember in the very beginning, so in the very beginning we had an object exp, okay, and we had like these guys in there, all right, and we had a type alias over here, right? We had a type alias like this, okay, and we were just using a's over here everywhere. Okay, and then we realized that what we're doing when we were doing the view, okay, we were doing something like this, and we were doing like something like a2, and this was a string, okay, and we were having this and this and that, and over here these guys, they were doing a2. Okay, and how did we solve this thing? Okay, so this is an object, so hold up, maybe like that. I just wanted to compile. Okay, so we're gonna do equals. Okay, that actually almost worked like this. All right, like that. What is wrong? I actually have no idea what's wrong. This looks fine to me, right? What is it? Identify expected, type A. Is there something? Okay, there's something wrong with formatting over here. Really, it doesn't like the space over here. Oh man. All right, so this is what we had in the beginning. And how did we solve this? Well, we created a trait, right? We created a trait called expression, and we put this a inside of there, right? And this allowed us to put like these guys inside, and this allowed us to make it abstract, so we weren't forced to do this. Okay, so now we're going to do exactly the same trick. We're going to go over here. We're going to see, hey, we have like all of these options, and before we didn't even need options, and now we need an either. So basically, we're going to have a second parameter where we're going to be able to stick the option inside. Okay, so let's go and do this. Remove that crap, like this, like that. All right, so we're going to use the letter F for that, and we're going to have a discussion why we're actually using the letter F, okay? And this F is going to have a higher kind so that option can fit in, okay? And now everywhere we use option, we're just going to use F, okay? And let's not forget that we need this F over here as well, which is over here. My neighbors turned out some music, which is always fun. All right, like this. Now, obviously, everything down there is not going to compile. So yeah, so before we created a trait so that we can vary a, now we can not only vary a, but we can also vary this, let's call it wrapper for now. And by the way, one interesting thing, if you're starting to look at, Tagless final, functional libraries, like for example, fs2, you're going to see that they're going to look exactly the same, right? So this thing is going to be called string, right? So there's a string of some effect and some a. All right, cool. So now let's go and fix the interpreter. So we're going to go to evaluate over here. We're going to go to the top, and we're going to say that this is still going to be an expression of int, but we're going to need to insert our options over here, right? And now everything down there is going to compile. Same thing over here. All right, option. Same thing over here. All right, option. Okay, so in the future, we, a bit later in the video, we're going to put an either in there. Okay, so over here, we're going to have option. Same thing over here, option. And let's see over here, option, like this. All right, cool. Now we have the same problem with the programs. All right, let's save the file so that Metals can help me out over here. All right, so let's see. So everywhere where we're saying expression A, we should be able to say option A. Okay, so I pressed like Alt F3, and then I like marked all the places where we're using the expression. So if I go down, okay, so now we need to do the same trick for multiplication. All right, option like this. And the same thing for the division probably. Okay. I started to use the minimap recently, and it's kind of cool because I visually see that, you know, the next arrow is over there. Also, by the way, another thing, if you're using VS Code was metals and stuff. So if it already, you know, compiled, and when I'm saying compiled, I mean also like if it already ran, right? Because like technically, if it's compiled, it means that there are no errors. But even if there are errors, but like, you know, Bloop and metals, they already ran, then you can press F8 and you're just gonna jump into the next arrow. And if you press F8 again, it's gonna keep jumping. And I believe Shift F8 goes back to the original problem, and it actually shows you run neighbor, blah blah. And if you, even if you start typing, I think it's gonna stay. So at the end, you have to press Escape to make it go away. Okay, super cool. All right, so let's mark these guys. Division. Again, I pressed Alt F3, and somewhere at the bottom, you should see that I have like 2 selections. Okay, so let's go over here, put an option. All right. Cool. And as you can see, everything was fine. You know, we didn't even need to change anything in the main. So everything is like sort of fixed to options now. Now, this is a good first step. Okay, so our programs, they're like almost like maximally abstract now. So if we were to go to our division, for example, over here, and we would realize, oh, you know, we actually need something else, not only option, we could at least go and have a different interpreter. Okay, so we're going to go over here, and I'm going to call it division either. Okay, so we need a tiny type alias, or we need to use the kind projector plugin, which we do, but let's use the type alias for now. Okay, so we're going to have either string or an A. And we're doing this because either has 2 holes, and expressions want an F which has only 1 hole. So basically what we need to do is we need to fix one of these holes, like one of these, and when I say fix, I mean like to put something in there to make it not variable. Okay, so this is going to be either, and we're going to fix the left side to be a string and the right side to be an A. So basically we're making sure that this either now has only 1 hole, this one. Okay, so now everywhere where we say option over here, we can just use either string or, okay, like this. Okay, and we can also use a the kind projector, which we're going to do after we've done with this. Okay, so now we basically have exactly what we wanted. Okay, so we can have over here a left. We can say division by 0, and over here we can also have a left. Okay, and we have division by so this is going to be division ended up having rest, and this one is going to be right. And if the standard library was a little bit more awesome, then others would have a zip, but it doesn't, so we need to do a little bit of magic over here. So we can either use our for comprehension, or we can use just the flat map chain, flat map A2 over here, okay, like this. So now we can essentially remove this, or remove that, mark all of these lines, and bring that over here. I think I did it right. Hold up. Oh yeah, we also need to put them in a tuple again. A1, A2, and we're gonna do just match, and we need more curly braces over here. All right, so we ended up, let me actually have more space so that you see the entire thing. Okay, so we ended up going through the monads. Okay, we're doing flat maps, putting them into a tuple, matching again so that we can have like this code that we used to have before. Now, as already mentioned, this whole thing is a good first step. However, if we were to go into our programs, and if we wanted to work with this, like somewhere over here where we have like the division in the middle, we would need to explicitly hard code over here that we need a division with an either. Okay, and we could do that. Okay, so let's go and grab this type alias. Okay, so we're going to go to program, and we're going to have this type alias over here. So now we can do that over here, right? But then we're going to run into issues over here, and these are exactly the same issues as we had before, because now, before we were going like from like no containers to options. Now we're going over here from options to eithers, right? So we basically would need up to, to fiddle around and to fit them into each other. Okay, this is obviously not what we want. So let's revert this stuff, right? Okay, so again, we're basically stuck fighting the compiler. And by the way, if you're about to read the original papers about Tagless Final, this is the thing that they call unstable denotations. And luckily in Tagless Final, we have a strong type system that helps us out over here, and it basically shows us that it's not going to compile. Okay, it wouldn't happen like this was the initial embedding, which we actually didn't take a look, but as already mentioned, this entire series is more focused on Tagless final and not on the initial embedding. Also, the time has come to relate this a little bit to the to-do app that we're going to rewrite. So if I go down over here, and I know that you guys are not super familiar with the code of the to-do app, but still. So if we go to the boundary, okay, so the boundary is just a trait, and we have an implementation of this trait, okay? The trait has a bunch of methods. So once we're gonna start rewriting this thing, probably in the next video, maybe 2 videos from now, maybe even 3 if I end up splitting this one into 2. Doesn't matter. Okay, so what we're going to do is we're going to introduce an f over here, right? And then everything over here, like all of these return things, okay, they're all going to be wrapped into an f, like this, okay? And this one is going to be like an f over here, okay? And so what we just did, like this first step that we have in the expression problem right now would basically be like this, that we basically in the implementation, we're going to hard code this type. So for example, if we had something like, I'm just gonna like toy around, okay? So if this was a zero task, for example, let's just return a, I just wanted to compile, okay? Then over here, like this would be hard coded that this boundary would return a zero task. Okay, so this is not like super important to understand right now. I just wanted to sometimes, you know, jump around and see, you know, like, and show you like the real like relation to you know, to the real applications. Okay, so in fact it might actually compile like this. Probably not. Does it compile? I'm surprised that it compiles. Oh no, it compiles, right? Because we didn't no, it shouldn't compile. What's up with metals over here? Is it doing some stuff? Compiles. Oh yeah, it compiles because I have an A over here. Funny. So the reason I'm showing you that is that basically was this design, was this first step. Sure, it's better, but if one day we wanted to switch from Zio to Monix task or to Cats Effect.io, we would need to go and rewrite actually some code, okay, which some people claim is not a big deal. Anyway, let's revert all of that stuff. Okay, let's close that and let's go back up over here. All right, so the next step would be to do the same thing as we did to our expressions, right? So we basically abstracted over some container like an option. We would need to do exactly the same thing to our interpreters, right? So over here, all of our interpreters for now, they're saying, hey, we're hard coded to be an option. So what we want to do is we want to have an f over here as well, and at the end of the video we're going to end up pushing this f down all the way down to the main. Now there is a problem with that. Let me actually open the console again. Now so as I already mentioned, like there's a problem with that. So if you were just to go and to say something like, okay, so this is going to be a def now, and there's going to be some f over here that comes in, and if we just go and change like all of these guys to options, sorry, from options like to f's, the compiler is going to start to complain, and it's going to start, first of all, we can't do this, right? And it's going to start saying things like, hey, map is not a member of f, or, you know, like zip is not a member of f, and all of these things. Okay, so what we need to do is a similar thing that we're doing in our programs, right? So our programs, they're saying, hey, this is going to be a DSL for some A, but I need a bunch of things that you know, that allow me to actually write some code. So we're going to need to do exactly the same thing. So we need to bring in some other DSLs that tell us how to map things, how to flat map things, and so on. Let me actually revert this because I want this whole thing to compile for now. All right. Now, luckily, we don't need to write all of these DSLs ourselves because these are very, very typical DSLs of functional programming, and there are libraries out there that come with those DSLs and with the interpreters for these DSLs. And by the way, this is a like another way to call them would be type classes and instances of these type classes, right? It's DSLs and the interpreters for these DSLs. Okay, now one of these libraries is Cats, and this is the one that we're going to start using right now. One of the important things to notice is that, and it's super clear because we're using a multi-build, that we need this dependency only in the interpreters and everything down the interpreters, right? So our DSLs are going to be fine. Our programs are going to be fine, I think. Yeah, I think our programs are going to be fine there. They're not going to need this dependency, right? So as you can see, like it depends only on the DSL, but we're having a change only in the interpreter, okay? So we're going to go over here. We're going to say settings, right? And we're going to say library dependencies like this, ++ equals, it's going to be a sequence of org.type level. And we're going to do this, and we're going to do cats core. The latest version as of right now is 2.1.1. All right. Let's not import changes for now. Let's make SPT happy first. So for now, like we're just adding the library, right? So we're not depending on any code from it, so everything should still compile. Okay, so now we can import the change. All right, let's go back to the terminal. So now what we can do is we can go to our interpreter over here, right? And now I can maybe, no, we can press Control Y. Yeah, okay. So now we have like exactly what I wanted. All right. So now we're gonna have like the same compilation issues, so like same as before. It's gonna say, hey, I don't know anything about map, I don't know anything about flat map, and so on. And now we would need to bring in those DSLs from Cats. And this is, by the way, like the thing, like everything that we're doing from now, this is what I believe like where most of the complexity of Tagless Final is coming from. It's knowing where to bring these DSLs from and what DSLs these are. So the issue is that if you're doing like functional programming like this, functional programming like to the max, what ends up happening is that you're basically not just allowed to write some arbitrary code. Right? So you can't just like go and like hack wild west. You need to be very explicit about the things that you need and about the things that you're going to do with them. And because of that, so basically you need to understand like every form of every possible program. So if you look at some program and you see, okay, there's some variable and it's being incremented and stuff, then you need to know, okay, so this is just, this is just a map, right? And then you need to know, okay, map is a thing. It belongs to a functor, and so you need to bring in the functor, right? So like this is where like most of the complexity comes from. We're gonna have a tiny discussion about this at the end of this video, or maybe at the end of the next video if I end up splitting this one into two. All right, cool. So what we need to do is we need to import cats. And if you have seen my my video about the introduction to cats, or basically the functional error handling with cats, then what I told you is that when you're starting out with cats, then you need these three imports: cats data, and cats implicits, like this. All right. Now in this one, first of all, we're not going to need data. For now, we're actually going to end up needing it a bit later in the video, so we're going to remove it. And for this one, we can actually go a bit deeper and realize that in this one, we only need the DSLs, right? So if you look at our programs over here, we did not need the instances of these DSLs, right? We did not need the actual interpreters, okay? We just needed the DSL that describes how to do these things. It's the same thing over here. It's just that these DSLs are coming from cats, so we don't need like the instances and everything that comes in from the implicits. But for now, let's leave it like this. All right. So what we're gonna do is, and I'm gonna teach you a little bit how I do this, but basically in my head, I need to traverse the so-called functor hierarchy, which is in cats, and to see what I need. So for example, one of the first things I'm seeing that there is a map over here. Okay, so I need to bring in a functor, right? I'm gonna call it like instance. Now I'm gonna call it interpreter, like this. I'm gonna call it interpreter. Okay, so and I'm gonna say functor. Right? So give me the functor for f. And now like this part is going to compile, but like all of these parts are still not going to compile. Okay? So for example, for this one, and by the way, let me actually rewrite this into a different syntax. Let me do interpreter. Hold on. Let me comment this out. Let me do interpreter dot map, right? Because I know that this interpreter for functors, it has a function called map. It wants the f of int in this case, and it wants this function. Okay? Now, the same thing over here was a zip. Okay, so we need to go over here. I need to say interpreter, and I need to know that there's a function called map2 because I have like two things that I want to map. And I'm going to do like a1, a2 over here, right? And then I would know that it wants a function which wants two arguments, right? So it's going to be a function that wants a1 and a2. So we don't need to have a partial function. Okay, a1, a2. Okay, and it's going to do a1 plus a2 like this. But now it's still going to say, hey, I don't know where this map2 comes from. And now I need to like go back like into my head and keep traversing the functor hierarchy, right? I need to say, okay, the functor is not enough. I need something more. I need apply. And now this thing compiles. But this one still doesn't, right? So I need to keep traversing the functor hierarchy. And I need to realize, okay, apply is not enough. I actually need applicative. Okay, and I need applicative because I know that I can use pure over here. Notice that nothing over here says options, so sum is not going to work anyway. It says, hey, you're giving me a sum of int, but I wanted an f of int. Okay, so now what I can do is I can say interpreter dot pure. right? So if you've seen my video about functional error handling, then you should be familiar with these two, and maybe actually even with this one. So what I meant before is, and notice like the rest of the code base doesn't compile, but basically what I meant before is that if I remove this, it's still going to compile. Like this part is still going to compile. In fact, if we actually had this, we would be able to use a different syntax for these guys. So instead of this, and I always recommend you to use this syntax, by the way, instead of this, we could say n.pure f. Okay, and instead of this, we would use this one, right? And instead of this, we would use a1, a2 dot tupled dot map, and now inside of it we would have like the same thing as we did over here, right? And there's a better version of this where you can just say map an instead of this, map an, like this, right? And because it doesn't need a partial function anymore, we can just do this. And because we're using like these guys only once, we can just do underscore plus underscore like this. All right, let me start cleaning this up actually. Okay, let's clean this up. Let's clean this up. Let's clean this up. And at this point, we're realizing that because we're using the syntax, that we're not even using this name, and this is why the context bound notation is so popular, right? So this, hold on, let me do this. So this behaves exactly the same, but it is much shorter, right? So this is why like this syntax is usually used. In fact, let's go and use it. All right. And at this point, I'm going to show you another import over here. So over here, you can say that you just want to have the syntax for everything. Okay, you don't need all the implicits. All right. So this was like a sort of like a slow introduction, and this is starting to have something to do with effect tracking again, but we're going to talk about this a bit later. Okay, so we have this guy now. So let's go over here. Let's do the same trick, def DSL. Okay, and we're going to have an f underscore. Okay, everywhere we say option, we're going to say f. Okay, and now we can just copy this guy over here, bring it down, and use multiplication. All right, so what's up with that? Yeah, we forgot to actually say that we need applicative. Okay, now in this case, actually, if we look at this and we're going to see, hey, we actually don't need applicative. We actually, apply is enough. Okay, again, like I did like this quick traversal of the functor hierarchy in my head, and I realized that I need this one. But I admit this is the most complicated part of this. Like, how should I know? How should you know that there is this thing that I need somewhere? Okay, and I always recommend you to use the syntax because on some occasions, occasionally the compiler will show you which things you need to bring in. Okay, I believe actually in this case, this is exactly what's going to happen. Maybe. Could not find an instance of functor for f. I'm not sure if a functor is enough. Is a functor enough? I don't think that a functor is enough. Yeah, so now it says, hey, I need a functor and I need a semi-grouple. Okay, so we're doing this. Yeah, so as you can see, like this would actually be enough, but I know like in my head that apply is a functor with a semi-grouple, right? I think, right? If I go into apply, yeah, it's a functor with an invariant semi-grouple, and an invariant semi-grouple, if Metal is going to help me, okay. Basically, if you were to jump in, you're going to see that this is basically a semi-grouple. All right, cool. So let's go to division, and let's do the same trick. So this is going to be a def, and we're going to have an f. Okay, and all of these options are going to be f's. All right, and now over here, so we're going to try to do the same trick, right? So we're going to do like a1.a2. We're going to do that, okay, and we're going to do dot tupled dot flat, right? So before we had like this, right? And then I told you that you can do like map n, okay? But in this particular case, I don't believe that there is like a flat map n or something inside of Cats, okay? So we're going to do flat map. Okay, and this is where things are gonna start like getting a little bit more complicated. Okay, so over here, one of the things that we're gonna realize, okay, so this is gonna be a flat map, so functor is not gonna be enough. So we need at least a monad. Okay, and because a monad extends applicative, then we know at least that right. So let's put a monad over here. Then okay, actually let's not put a monad over here. Okay, so let's be very precise. Okay, so we're seeing over here that we need a flat map. So there's a type class called flat map, right? So there's a DSL called flat map. Okay, now we're going to keep looking and we're going to see, okay, so over here we're going to need to produce a left. In fact, let's go and copy these guys. So over here we're going to have the left, and over here we're going to use this left, and this left, and over here we're going to use this right, Well, actually for this one, I didn't need to copy it. I can just do red. Okay. Cool. So we already have flat map. And then we also need to create things. We have already seen how to create things, right? So we can just go and say, that pure f. And for this, we would need an applicative, right? By the way, notice that I'm not saving the file. I'm just showing you like what things you would need to do. And you should know the flat map and applicative is a monad. Okay, so this is a monad. Once it compiles, we could jump in and see it. Okay, but we also need to create errors. And creating errors, we basically need an applicative instance for errors, and this applicative instance for errors is called applicative DSL for errors is called applicative error, right? So we also need applicative error, okay? And I also know that applicative error and a monad is called a monad error, okay? It's not going to compile like this right now. We need some extra things, but at least for now, okay? So now over here, instead of left, we will be able to say raise error. And we need to specify f over here and int over here. Okay, so we're gonna do this and we're gonna do that. Actually, let's have it down like this, maybe down like that, maybe down like that. I'm not sure if Scala FMT is going to be happy about this or not. By the way, before we're using this syntax, let's actually use the regular syntax over here. So let's say that this is going to be implicit monad error for f. And our errors are going to be strings. Okay, so we need to say strings. String, come on. String like this. All right, so now everything over here compiles except for this guy. What is wrong with this guy? I still have left. Hold up. Like this. All right, at this point, we don't actually need this whole other thing. Like that. Okay, so let me actually create more space so that you guys see the whole thing. Okay, now this context bound notation is going to look a bit more weird. So either we're going to do like the same thing as we did before, right? So we can do something like type monad with string error for some f. Okay, it's going to be a monad error for f and string. Okay, and then we will be able to use this type over here. Okay, and for f like this. Okay, or with the context bound. Actually, let me do this so that you guys see both, because like the context bound that we're going to use now is going to start looking really weird. Okay, so let's remove that guy and let's go over here. I'm going to say monad with string error. Okay, so this is like the same thing right now. Okay, so let's remove this one. Okay, so as you can see, it compiles. Okay, but we could also use the kind projector. So if we go to dependencies, we're going to see that at the bottom, we're using the kind projector, and in our builds, most of the projects, they have settings, common settings. And common settings is this thing at the bottom, which has a couple of flags, and it has this thing at compiler plugin, which has this kind projector plugin. Okay, so if you're doing Scala 2.13, this is all that you need to do. And in Scala 3, it's actually going to be part of Scala, so you won't even need an extra plugin. Okay, so let's go over here. With this plugin, basically what you can do is you can just say over here monad error, right? And you're going to say that on the right side is going to be a string, and on the left side, you basically need to describe this f somehow, right? So this f, and the way you do this was a kind projector. You have a star, like usually this is enough, but in this case it's a higher kind, so you need to do this thing, which kind of looks weird. Okay, so notice that nowhere over here we're now using this type alias. Okay, we're actually going to use it like this because on one hand, like for education, this is a bit too much, but if you're going to start like looking at other functional libraries, they're all going to use this thing. Okay, so and there we basically have it, right? It's completely abstracted away, and now we're going to go and fix the rest of the application. Cool. So let me scroll up. Okay, so we have the cats so that we can use applicative, and we have the syntax so that we can use like all of these syntax tricks. Okay, let's do this. Let's close this one. Let's go this one. Let's go to the view. Let's do the same trick over here. So everywhere where we say option, we're just going to say F. Everywhere where we have val DSL, it's going to become a def DSL, which receives this F, which has a hole like this. So let's see. All right. So over here we need an applicative. Okay, so that we can say .pure.f. By the way, did I have the parents over there? No, I didn't. All right, cool. So we have this over here. Like this can stay, doesn't need to change. This will change just a little bit, right? So it's going to be a1, a2 dot map n. It's going to be a1, a2 arrow to the right, and that thing is going to stay the same, like this. All right. And by the way, because we're not using options, we're using f, like this line is going to become shorter. And it should be enough for that. Yeah, it should be enough. Cool. So we have map and again, for string interpolation, we cannot use underscores. All right. So let me just do that. And over here, we're going to say that we just need apply. And we're just going to paste it over here. Let's this time not forget to do this. We can join the lines. Oops. We can join the lines over here, like that. All right. Why did I have this? All right. So that's what we have. And let's do this over here like this. And what we need to do is we need this, and this is going to be division. Okay, and this is like, again, like this is where it starts to be clear again, like why people are talking about effect tracking all the time, because now over here we're seeing that this division, it only needs apply, right? So you kind of have like in the type, you see that there is no way that there's going to be errors over here, okay? Whereas in evaluate, you're going to see over here that there is going to be some errors. All right, so let's go and teach our programs to use f as well. So everywhere where we say option, we're just going to use f, okay? And this f is going to be injectable. So first of all, the program also needs the f. Okay. And everywhere where we say DSL of A, we're going to use an f over here as well, which is going to have this. All right. And program A is going to be program of f comma A. And yeah, look, there are no error lines over here. So this whole thing actually compiles. Awesome. So basically we have f everywhere and it needs to come in somewhere. Now let's go to our main. Let's save the file and we're going to see that it's not going to work. It's not going to work only at the bottom, which is kind of interesting. Like all the others are going to compile. That's weird. Right. So what is the error? It's going to say you could not find an instance of monad for f. All right, so every time you basically see this, you need to import cats implicits. Or technically, look over here, we're importing cats syntax all. Let's actually copy that. So let's go to main. Okay, so let's do it over here. Okay, over here we need all the instances. Right, so we don't even need implicits. So we're going to say import cats instances.all. Okay, and now it's not going to compile for different reasons. All right, so it took some time, but basically it says divergent implicit expansion. Okay. This is the most confusing error message in probably most of Scala. And every time you see this, it basically tells you that it cannot figure out the type. So my hunch is that the type reconstruction algorithm is not deterministic. So it probably tries to figure out the types from both sides, like from two sides. So it tries to figure out like the type over here and the type over here, right? So remember, like all of them need types. So this one, expression.dsl, it would need expression.dsl, it would need an f. Okay, and the program itself, like all the DSLs, that would need an F and an A. So what I'm guessing what is happening is that it tries to figure out the type over here, and it tries to figure out the type over here from both sides, and then it realizes that it's not going to be able to do this from either of these sides, and it's going to start like digging itself into a hole, and before it, like a recursive hole, and before it does that, it basically gives up. Okay, so basically all we need to do is we need to help it out with some types. So like 99% of time, when you see this like divergent implicit expansion error, you just need to find the place where it's breaking and annotate the types. So before we do that, let's actually take all of these guys and comment them out so that we can fix them one by one, like this. All right, so now we have only one error at the top. Okay, so we want to have like a valid expression.dsl. So if you go in there, which it might be able to jump in. Okay, so it just needs an f that has an implicative. Okay, and why didn't it jump back? All right, so even though we don't need it, we could say that we need an f. Our f is going to be an either. It's going to be either that on the left-hand side, it's going to have whatever we want, because we know that this expression is not going to produce any errors, right? So we can put like string in there or whatever. We're actually going to put nothing because, like, you know, we want to kind of like denote that nothing is gonna fail. Okay, so we're gonna have a star over here. Remember, this is kind projector again, because we need to put an f over here which has only one hole. So we're gonna say that the hole is going to be over here, the other type is going to be fixed to this. Okay, so this is going to be this DSL, and as you can see, it actually works. Okay, so it wraps it into an R. What we could also do is, for example, like as I already said, like it doesn't matter what we have on the left, right? And this works because there is an instance of applicative for either, which comes from over here, right? So now it's going to say, hey, I could not find applicative. Okay, cool. So what we could also do is we could use an option over here, right? So we can just say option. Okay, and now the whole thing is going to be wrapped into an option. Another thing that we can do is we can actually use ID, which comes from cats, right? And ID basically means that there should be no wrapper. And I'm actually going to show you how it looks like. ID is a type alias, identity of A equals A, right? This is a weird looking thing. It basically says like something inside of a box is the same thing as like not inside of a box. Okay, so basically we can have a function, you know, plus. This is going to be the first version of plus. It's going to take an integer and b integer, and it's going to produce an integer just by adding them. Okay, so what this thing allows you to do is it allows you to have like gazillion versions of these, right? Where you can you know, mix them however you want. So for example, this integer is going to be identity, right? And this one is going to be ID, right? And this one is going to be int, and you know, this one is going to be ID. This one, whoops, ID of int, and this is going to be identity of int, and this is going to be int again, or let's, you know, wrap it in ID, right? So the point is that at any position where you see int, you can put ID of int or identity of int, right? It's kind of confusing the first time you see this, but it works out. Why? Why does it work out? Because there is an instance of applicative somewhere, you know, for ID somewhere over here, right? So if I remove this, okay, maybe it's in there. Okay, so hold on. Maybe if I do, actually, maybe no, hold on. There has to be one. All right, it's like this. So let's try to do this guy. Okay, so for applicatives, we don't even need this, which is cool. All right. Anyway, so this is going to be ID. This is going to be ID. All right. Now, if we scroll down, like before we start like fixing things, if we scroll down over here, we're going to see that we're using multiple DSLs, right? And all of these DSLs, they will have exactly the same type, right? So we need to go and put ID over here, ID over here. And with ID, it's not such a big deal, but if we have like this long either, then we need to put it over here and over here, right? We can help the type inference algorithm from the other side. We could specify the type over here. It's going to be much more convenient. So let's do the same trick again. So let's revert that. It's not going to compile. All right, so now we can go and we can put over here. Remember, it needs the F and the A. Okay, so this is the program, so it needs to know that this is going to be an either of nothing and star and an integer. Okay, like this. Or we can go over here and we can say we need an option, or we need just an ID. Okay, so for the remainder, I'm going to use like the least powerful type possible. Okay, so we go over here. Let's go and see our view. So for the view, we just need the int. I'm sorry, we just need the ID. All right, let's keep going over here. Same thing. Okay, so this is going to be ID int. This is going to be enough. Over here, same thing. I'm going to say ID. No, that's a string. That's for the view. All right. Okay, over here, same thing. ID int. And this guy is going to be ID string. ID string. This one is going to be, okay, so this one is a division. Okay, the division is the most exciting one, right? So if we just do ID int, it's not going to work out, right? Because it's going to say, hey, this guy, it needs more. So if we jump in there, it says, hey, we need a monad error, and it's going to say cannot find an instance of monad for cat's ID, right? Even though we have like all of the imports. And basically this is where it tells you, hey, we need something strong over here. So over here we're forced to say that this is going to be an either, where on the left is going to be a string. Again, like this thing is hard-coded over here. On the left there should be a string, right? So this is going to be an either string or star. Okay, and only now it's going to work, right? So over here you can't just go and say nothing like we did before, right? It's going to say, hey, I actually need a string, right? Which is super cool. Like this is sort of like the creme de la creme of software development, right? So at the very bottom, you can just say, hey, wrap this thing into this, okay? We're giving a lot of power to the interpreters, but we don't need to rewrite our programs, and we don't need to rewrite our DSLs. We can just add new DSLs, write new programs and stuff, and so on, okay? And this is like, again, like the power, and, you know, again, this has something to do with effect tracking for the view, right? So this is a view for the division, right? For the same expression, but the view is actually fine with just the ID. right? So now we like 100% see it in the types, okay? So even though the division itself, it needs to be wrapped in an either, the view doesn't need to be, all right? So let's go and do the same thing over here, right? So this is going to be a DSL of either, where on the left it's going to be a string, and over here it's going to be a star. The right thing is going to be an integer. All right, so this is not the right thing, remember, this is the second parameter, okay? Again, if we look into our programs, it needs two things. It needs this so-called effect type, and it needs the other type. All right, and over here, this is the last one, and we're going to use an ID over here, ID of string. All right, again, like for viewing, an ID is enough.